My name is Magnus Hagander. You're hopefully here to listen to something about Postgres. If not, you misread the schedule and went to the wrong room. My name is, as I said, Magnus Hagander. I work for a company called Red Pill Inpro. We're an open source services and consultancy business based in Scandinavia. So we're in Sweden, Norway, and Denmark. I'm out of Stockholm in Sweden myself. Thus, starting at 10 a.m. the first day after you arrive is very nice. So I lead up our database offerings that are based primarily around Postgres. We do a whole bunch of other things, but I try to stick to the database side as much as I can. Within the Postgres project, I'm one of the Postgres core team members, the steering committee for the project. I'm one of the committers on the code base, though I don't do as much as I'd like to, because too many other things to do. And finally, I'm also serving on the board of Postgres Europe, which does sort of similar things to this, but in Europe. The schedule here for the Postgres day, or the Postgres track, I should say, through 2 days here is managed by Postgres US, which is our US sister organization. But I'm always happy to come over here and talk to you guys as well. So enough about me. Let's talk about Postgres. Who is already using Postgres 18? Okay, that's good. That's good. It doesn't exist. So that's good. Who's using Postgres 17 today in production use, is what we're saying. Okay. See, 16. Oh, it's pretty good. 15. 14. Getting there. Okay. 13. 12. Okay. You guys have a job to do, right? You're aware that 12 is end of life, I'm sure. So you're already in this panic state of trying to upgrade. What about versions older than that in production? Oh, that's fun. What about versions that had a single digit as their first number, starting with a 9? See, don't run those in productions anymore. Please don't. I mean, they work, right? But they're very far from being supported. So no, we're going to talk about Postgres 18, which is then the upcoming version of Postgres that, again, does not exist yet. Maybe don't run it in production just yet. If you want to run it in testing, by all means, please do. But it's a little early to run it in production so far. So looking a little bit at the development schedule to get us to where we are, or where we're with Postgres 18. So those of you who've seen me do these talks before about the new versions will recognize this thing. This year, I remembered to replace the years. Last year when I gave this presentation, I think it was here in Pasadena, I forgot to replace the years and just replaced the version numbers. But we've stuck to a pretty strict scheduling for many releases of Postgres now, which is we started what will become Postgres 18, basically in July of last year. And the way that we do this in Postgres is we do all of our feature developments on the main branch, and then we have release branches. So what happened in July was that we created the branch release 17 stable, and that's what then in September became released as Postgres version 17. That's just a general software development tip, right? If you're having trouble stabilizing your code to be ready for release, just create a branch called stable, and now your code is stable. It's very easy, it works great. But what it means in the form of Postgres development, so at that point we separate out 17, all work goes into stabilizing it and getting it released, but it also means that the main branch gets opened up for new feature development then into what becomes 18. And in Postgres we use something we call commit fests. It's just our way of doing iterative development. Everybody has their own little terms. The idea here is that we spend a month building features, and then we spend a month reviewing and committing those features. There's a lot of arguments of whether how well we actually stick to this process, but that's the general idea. And then, of course, at the end of one of these commit fests, the idea is anything that's not ready gets thrown out, and then we start the cycle over again. So we've run so far 4 completed commit fests. July, September, November of last year, we ran one in January. And then the 5th and final commit fest for Postgres 18 started in March, which is a couple of days ago. So it's currently in progress. It has barely gotten started. So what that means is we're pretty far from what is Postgres 18. Now there's a general rule, guideline, what we want to call it, that nothing completely new can get put into the final commit faster, if it's anything but very small. But there are a lot of fairly large things that have been reviewed and gone through this cycle many times that are still in the queue. And they may very well make it into what will become Postgres 18. And likewise also things that are in Postgres 18 now may go away. Something was reverted just yesterday, I think. Luckily, it was not something that I had put on my slides, so I didn't have to update them. But these things happen all the time. So the things that I'm going to go through some of the things that I've found so far that I think you would be interested in version 18. It's not a guarantee they'll still be there when the release comes. And even more so, there will be many more things that aren't in there yet. But we still have a pretty solid set of features that are coming out for 18. So an almost truth, so saying the current status of what it looked like. This is actually the status on, I think it was Sunday. We had 1,810 new commits into Postgres. Now, Postgres still here applies a methodology similar to sort of how we work with commits and things, is similar to how we used to work with things when we did things in like CVS and these. So really a Postgres commit would be the equivalent in most cases of a git merge, right? We basically do consider them git squash merges of the features. So that's 1,810 individual merges is the equivalent. So you can't really compare commit counts. As you can tell, that's quite a lot for half a year, or a little bit over half a year. We've had some 3,500 files modified, 150,000 new lines of code, 73,000 deleted. Also, obviously, these numbers are going to go up. They don't really tell you much other than there's a lot of stuff that's already in what will become Postgres 18. So let's talk a little bit about the features that we've added. I usually group these into 4 groups. I'm going to talk a little bit about DBA and admin. I'm going to talk about SQL and developer. I'm going to talk about backup and replication. And then, of course, everyone's favorite, performance. Right? Today, I will say this list is a little bit skewed so far to where like some sections of these are very small. I think they will actually end up evening out more when I look at what's in the queue for 18. But we'll see about those. So let's start with the important stuff, right? What's going to break? There's always a couple of breaking changes. They aren't major. When we look on the building side, most of the breaking changes that we're seeing so far now, I think, are going to be on building sides. For example, we have removed support for the HPPA risk architecture. Anyone using that? Anyone ever used that? Like there aren't any people quite that old, right? That's not true. HPPA has been around for a while because those machines just didn't die. But this is not going to affect you. Likewise, Postgres has removed support for building without spin locks and atomics. Like we've had these things in our CPUs for at least, I don't know, in even the cheapest CPUs for 30 years now, I think. This is not going to affect you. These are just sort of cleanup processes. The thing that might affect some people is that Postgres dropped support for OpenSSL older than 1.1.1. If you are stuck in an environment where you have to build Postgres for really old versions of your operating system, this can become a problem. But maybe you should consider if you're really going to run, the latest and greatest Postgres on a 20-year-old operating system. This is kind of an unusual combination, but if you do have that combination, you may run into trouble with that one. I think this is really today the only big breaking change. So for those of you who've been with us for many years through many upgrades, this is an unusually short list. There is usually something else that will break one way or another. Most of the things that breaks are things you weren't supposed to do in the first place, but if you did them, it still broke. Okay, let's talk about the things that are actually useful. Let's talk about things that are being added. I'm going to start by a change, which is actually a feature. It's a changed default that I personally very strongly believe in. Postgres will now enable page-level checksums by default. We've had page-level checksums since, I think, Postgres 9.1, or was it even 8.1, like ages and ages ago, but they have not been enabled by default. So you had to remember to turn them on. Did you? Probably not. As somebody who works, as a consultant, I work with a lot of different customer systems. I think I've so far come across like 1 or 2 customers who actually enabled it. And then you explain to them what they do, and they were like, why didn't we enable that? And that's a good question. So it will now be enabled by default. If you don't need it, if you don't want it, you can still turn it off. You give initDB the no data checksums, you're back to what it was before, but you probably want them. And one big difference is you can change, like if you've installed the system, you've initialized your database with checksums, it's really cheap and simple to turn it off. You stop your system, you have to stop it, and then you say PG checksums disable or whatever it is. It turns it off, it takes less than a second, you start it up again, you're good to go. To turn them on an existing system, you have to rewrite the whole database. There's still a tool that will do it for you, but you're looking at non-trivial downtime if your database is of any size. So the default is better. The other thing to remember, this does not affect you if you upgrade. Right? If you upgrade from a previous version using PG Upgrade, if you didn't have checksums in 17 or 16 or wherever you're upgrading from, you will also not have checksums in 18. So the default only comes on new installs. If you're upgrading using PG dump and PG reload, or if you're upgrading using logical replication, then the new default will apply because you have an actually new cluster, not an upgraded cluster from the database perspective. But if you're just doing an initDB, you will now have data checksums. And speaking of upgrades, another thing that I think is going to help a lot of people around upgrades is that Postgres will now transfer statistics on PG upgrade. Now, first of all, you've got to think of, there are two things here. We have Postgres has PG stats and PG stat, just to confuse you, right? PG stats are the optimizer statistics, right? The ones that we collect using analyze, the ones that tell you, the distribution of values, how much of your data is null, all of this data that the optimizer uses to build a good query plan. And then PG stat is the one that, PG stat user tables tells you, how many index searches you've had, all of these things. PG stat is not being upgraded. PG stats, your optimizer statistics are now transferred. Now, traditionally, when you do PG upgrade, the last step, it says, run this vacuum db -- analyze in stages, and then spend anything from a minute to 3 hours before your database is upgraded. And until you've done that, you get really terrible query plans. And particularly on large databases, this analyze in stages takes a lot of time to run. Postgres 18, you will not need this anymore. It will transfer the existing statistics from your system. You will be able to start it up immediately after the upgrade. So potentially, I would measure upgrade times can go from 4 hours, if you count this thing in, down to maybe 2 minutes. Like it's that kind of a difference if you have this need. So I think this is going to be a huge feature for those. Now, technically, this feature is actually in PG dump because PG upgrade uses PG dump. So you can use this if you are upgrading using a dump and reload as well. It's just usually if you're using a dump and reload to upgrade, this is not the part that takes the most time. It's the actual reload that takes the most time. But I think it's going to be a big improvement for that one. Then let's talk a couple of things around authentication. Who's using Trust for their database for all logins? Stop doing that. For many, many years, the gold standard in Postgres was to use MD5. MD5 is terrible. MD5 has now finally been officially deprecated. Right? MD5 is what we used to use for username password login. In Postgres version 10, we changed that to support SCRAM-based and SHA-256 authentication, which it's not just the change from MD5 to SHA-256 that makes it better. It's the whole SCRAM challenge response. The Postgres MD5 authentication has bigger problems than MD5. In fact, the MD5 part is not the biggest problem. It has a bunch of other issues, which is why it's been sort of soft deprecated for a long time. It is now hard deprecated. You will get your logs filled with warnings. Right? When you set a password using MD5, you will get a warning. Right? You can turn these off, right? You can set MD5 password warnings to off if you absolutely have to, but don't. Fix your system instead. Use SCRAM for your password-based login. It's strictly better in every possible way. There are no drawbacks. When Postgres 10 came out with it, there were drawbacks because you, for example, couldn't use older versions of the client. You couldn't use older versions of the Java driver or things like that. But Postgres 10 is 8 years ago. Right? Postgres 10, 11, and the 12 are unsupported at this time. If you're still running that version of your client drivers, you really need to update your client drivers. And then the problem goes away. So yeah, MD5 finally officially deprecated. We're getting rid of it. If you want to dig into some more complicated authentication, Postgres 18 will support OAuth bearer tokens for authentication. Now today, this is kind of useful to a level, but to really use it, you have to write a server-side provider, right? Because it has to know what to do with this OAuth data. There is no such provider that ships internally in Postgres, but we would kind of expect that the early implementations of these are probably going to be people like Azure and AWS, who will then build an OAuth bearer authentication that plugs into their existing infrastructure for user authentication. But OAuth, as you know, it's an open protocol. A lot of things can be done here. I would expect we will also, over time, hopefully pretty soon, see some generic OAuth plugins to run on the server side to integrate with, other well-known systems out there. And we've also added the ability to do Scram pass-through authentication if you're using Postgres foreign data wrapper. That is, if you're using today, right, if you're logging into a Postgres and then you have a foreign table using Postgres FDW that sits in a different database, you have to create a user mapping in your first Postgres server that contains the password in clear text. It's protected, but it's in clear text, of the user that you're going to connect to at the other server. Now with Scram pass-through, you don't have to do that. You can turn on Scram pass-through on the first server, and then if I log into the first server, that one is able to use my credentials to pass through to the second server. And as long as I have the same Scram identifier, which means I have to have the same salt and iteration count, so you can't have different Scram configurations, but as long as you have those, you get a pass-through authentication to the next server. So for example, if you're using this to do sharding or something where you have some tables on different servers and stuff, it works similar to Kerberos delegation, if you've been using that for Kerberos-based logins, but for Scram-based passwords. So yet another reason to switch to Scram, not just to get rid of your MD5 warnings. And these are all good. If you're using TLS, Postgres has had a bunch of configuration things that just didn't go all the way. We've supported TLS 1.3 for a long time, but when you configured explicit cipher suites, you couldn't choose the ones that are in TLS 1.3. Well, now you can. If you're using TLS 1.3, you can, since before you can configure your system for like a minimum usage, a minimum version to be 1.3, for example. We now also support multiple versions of the ECDH curves. If you have specific crypto requirements where your people are saying, well, these are the only ones that are approved, in my environment, I have to use these, you can now lock these in. And speaking of crypto, I mean, this one also comes out nice. Like, you can now disable the crypto in PG Crypto. You're like, okay, well, what's left if we disable the crypto in PG Crypto? Well, PG Crypto, right? It has hashes, it has simple encryption, there's PGP support and a few things like that. It both has a built-in version, and then it can run on top of OpenSSL. And the reason you want to turn this off is if you're in a FIPS environment where FIPS puts requirements on which crypto is available at all. Even if you use it or not, it cannot be available. If you turn this off in PG Crypto, it will fall back to only have the OpenSSL versions, and then you have an OpenSSL build that is FIPS certified. Now PG Crypto becomes okay for FIPS. So it's mostly a compliance thing, but there is a bunch of things left. Then, I said we were in the section of DBA and administration, so luckily we have, some more things about vacuum. We all love vacuum, right? There are a couple of I think, really useful things to improve our handling of vacuum, there are also a few things on the performance section, but in the admin side, we have a new configuration parameter called auto vacuum max threshold, because auto vacuum was too easy to configure, so we had to add another parameter. The idea, right? So the simple ways of how auto vacuum works, right? It calculates a number that is the number of rows in the table times auto vacuum scale factor plus auto vacuum threshold, right? And it gets that number and it says when this many rows in the table are dead, so modified or deleted, then we run vacuum, right? That's the simple case to it. And the default value here is 20% and 50 rows. So when 20% of your table has been updated or deleted, plus 50 rows, then we run the vacuum. Now, if your table has 10 billion rows in it, how much is 20%? Too much, right? So how do we deal with this today? Well, we do things like some people run vacuum manually, sometimes you do an alter table and you set this percentage to a much lower value. So we're giving you a new way here. Auto vacuum max threshold, you can, for example, set it to 20 million. Or the default is 100 million. That says if this value calculated by 20% of your number of rows gets above this, we use this value instead. So for your 10 billion row table, it will now start vacuuming at 100 million instead, because that's sooner. And you can set this much lower if you want. So question is this a table only or overall? So there is a Postgres, you set it in postgres.conf globally, but you can also set it on the individual table with alter table set. So you can control this very carefully in these areas. And the 100 million default is kind of, I don't think you're ever going to increase it. It's already starting at a pretty high number. I think we're going to see a lot more cases where people want to decrease this to vacuum more frequently. Because I think that's, and again, seeing what I see when I go out and talk to different customers, it's a much more common problem that people, when they have problems with vacuum, they try to vacuum less. But the solution usually is to vacuum more. And this will help you find that balance more. You can now change auto vacuum max workers without restarting Postgres, which is great. Of course, to do this, we created a new parameter called auto vacuum worker slots, which you cannot change without restarting Postgres. It's still helpful, right? Because changing auto vacuum max workers, that's a tuning function, right? You might need to change this. Whereas auto vacuum worker slots, the cost of having a high value in auto vacuum worker slots, like 20 instead of 3, is not that big. And then you can even dynamically, or at least manually, tune this auto vacuum max workers within this window, so up to this number. So we didn't magically remove the problem, we just basically split the parameter in two and made one of them much cheaper and easier to tune. So that's max, right? That's max. This is the max worker, yeah. The vacuum command and the analyze command have gained the only option, which forces it to not recurse into partitions, for example, or recurse into table inheritance, but nobody really uses table inheritance, I hope, other than partitioning. The idea here is if you run vacuum, like a partition table in Postgres has this little fake table that has no data in it, and then it has all the partitions under it. But if you run analyze in particular, on the root table, it will analyze the subpartitions. And you may not want to do that if you have many subpartitions, but previously there was no way to actually do this on the root table without recursing into all the partitions. Now you can say only, just like Postgres already had, like select only, that would select only from this table. Explain analyze. It's been enhanced with some more information. Buffers is now enabled by default, so you don't have to type that anymore. I think that's from all of us typing it every single time, and we're like, can we stop typing this now, please? And got that fixed. It will show much more statistics about parallel bitmap scans. It'll actually show what happened in the different parallel sessions. It'll show how much memory and disk was used for materializing nodes. Previously, it would just say, oh, I materialized this here. And it never told you what the cost was. So basically, the explain analyze default output will contain more information, and the verbose output even more beyond that. So further data in there. The copy command has gained another log level. Hopefully, you're all aware of the fact that since a few years now, you've been able to do copy from, and you can say on error ignore. And then it would say, copy and say 2 rows were skipped due to data incompatible. Like I tried to load a string into an integer field or something. And you could set log verbosity to verbose, at which point it would log every row that failed. But you couldn't actually get it to shut up. Well, now you can get it to shut up. Log verbosity equals silent. Just runs the same thing, but ignores those rows without telling you about it. Yeah, I love statistics. Sorry?
So will it have the same effect when you do file for a data wrapper because it uses copy under?
So the question is, will it have the same effect if you use the file foreign data wrapper? Yes, I believe this option is also available for the file foreign data wrapper. So yeah, as someone who often also has to deal with tuning other people's system, statistics is great. Like now we are talking about the PGStat system that tells you what's going on, right? And there are a bunch of new really useful statistics that are coming to you to let you see how your system operates. Parallel workers, we have two new fields. I love the names of these, right? Parallel workers to launch and parallel workers launched, right? Both these fields are added to both PGStat database and PGStat statements. This will help you tune your parallel query, hopefully, right? Because it basically says, you have the max parallel worker processes, tells you how many parallel workers are allowed in the system. If they're always enough, then these two numbers will be the same. But if you see that it's a higher number of parallel workers to launch than parallel workers launched, that means Postgres made a query plan and said, hey, I could use 3 extra processes or 3 extra CPU cores to run this query, but they were not available. Right? Maybe it's a fact of life, but maybe it isn't, and you could actually tune the system to let this query use more processes, thereby running faster. And again, you can see it grouped by database in PGStat database, and of course you can then sum it across PGStat database and get the global stats. And you can view it for an individual query in PGStat statements, because everybody's using PGStat statements, right? Is anyone not using PGStat statements? Nobody puts their hand up. I think that's the first time that everyone's using PGStat statements. Finally. So we have some vacuum stats in PGStat all tables. So for both your tables and the system tables, you now have total vacuum time, total auto vacuum time, total analyzed time, and total auto analyzed time. So it just tells you of these 125 auto vacuums that have run on this table, how much time did it take in total? And then you can divide it by the number and you get the average time, right? Added on a per table basis. We also have something interesting in PGStat progress vacuum and PGStat progress analyze. We now get timers for how much time was spent delaying. Right? So vacuum in particular, auto vacuum has this cost-based delay where it intentionally slows itself down to not overload the rest of the system. These numbers will help you figure out how much of the time was actually spent slowing, like how much time has it spent slowing itself down. Now there are discussions right now going about sort of adding some stats that actually show us both of these, because right now this data is only available in these progress views, and as soon as your vacuum finishes, this goes away. So if that might not make it into this version, but at some point it should hopefully be sort of merged and available along with this stuff. Our write-ahead log stats are now tracked in PGStat IO. A couple of versions ago we gained this new, more granular IO view that tells you, divided by backend types and stuff, like where's your IO coming from. The WAL IO has now also been merged in there, so you can see, you still have the global stats in PGStat WAL for some of it, but the actual IO is moved. You used to have a global value. Now you can see how much of the WAL is generated by the checkpointer, how much is generated by normal processes, how much is generated by auto vacuum. Like this type of split up is now available, so more details. And also the flag for wall buffers full, or the counter for wall buffers full, like how many times did you run out of the memory buffers for your wall, has now been added to PGStat statements. So you can see it per query, where this has happened, not just, oh, it happened, I wonder why. It's been added to vacuum analyze in verbose mode for this particular one. Did we run out? And it's been added to explain if you add the wall parameter or wall flag to it, you get that. Then again, we still have the global value as well. So lots more interesting statistics coming up. Okay, let's move on and talk a little bit about SQL and developer side of things. What do we have here? What do we have for you who are developers? Well, Postgres 18 will add support for UUID version 7. I still personally think this is really weird because UUID has like 7 versions. Actually, it's 8 versions. And it's exactly the same UUID. There's no difference in the UUID. It's only different in how you generate it. So it's really the generation function version 7. Primarily, Postgres had a bunch, but primarily what you've used, and if you just say PG random UUID, you get UUID version 4, which is a completely randomized 128-bit number written with weird dashes in it. What UUID v7 does is it takes a part of this and says, actually, this part is sequential, and the rest is random. So the default says that the first parts of it will be the millisecond, like the epoch counter in milliseconds, basically. Then there is a 12-bit implementation defined, and then the rest is random. Postgres has defined this 12-bit to be sub-millisecond timing, so that you will have more than the standard level of sequentiality. And also, if you generate multiple UUIDs in the same session, they will always be sequential to an extra 12 bits. So as you can see, example here, I've just selected UUID v7. You'll notice the beginning is the same for all of them. If you actually used UUID v4 or the generate random UUID, they would be completely random. So why is this good? Well, this is good in a couple of ways. One big thing in Postgres is indexes, right? You get a massive write explosion if your data is completely random, and your indexes get much happier if you're sort of sequentially. So the idea here is they are still random, they're just not 128 bits of randomness. There is, for most use cases, still by far enough randomness, but then you get the beginning of it to be sequential, which means the indexes are going to be much happier. You can also, there is a function that you can take one of these UUIDs and pass in, and it can extract the timestamp. So you can actually see when this UUID was created. That's part of UUID v7. So I think this one's going to be really useful. One thing that I know I'm really going to like is the ability to use old and new for returning. Right? You know, when you do an insert, an update, or a delete in Postgres, you can say returning. But this one will now let you return old or new. So in this case, you know, update set a equals to returning the old and the new value for this one. Same thing if you do an insert, of course, then the old value is going to be null because there was no previous value when you did an insert. When you do a delete, the new value is going to be null because there was no new value at that point, right? So this lets you inspect both the old and the new instead of first having to query it and then doing an update, right? So that's really useful. But one thing that I think this is going to be even more useful for is it works with insert on conflict. So you can now determine whether your insert on conflict actually generated an insert or an update, right? The idea is we do something like here, you know, insert into T the new values, on conflict instead update the counter. Right? This is a pretty classic one, and traditionally you wouldn't really know whether it updated or not. You can get all the data, but here you can see that the first one generated null 1 for, you know, old new, and then it generates values. So by looking at this value, whether it was null or not before, you will actually know whether this value existed when you insert it. And I found that to be a fairly common thing when I look through applications where, oh, I would love to use insert or on conflict because it's much faster, but I have to actually know whether I created an object or not. So I have to select and check it first, and now I've lost the whole point of insert on conflict. So I think this is going to be really useful for a lot of such applications to know that part. We've added support for virtual generated columns. So, you know, it's just like stored virtual columns, except they're not stored. They're recalculated on each read. The biggest difference between stored is, of course, well, it's not stored, so it doesn't take up space, but you also can't index it. But it gives you an interesting option to create sort of a hybrid between a table and a view, because you can create a table, and then you can add a couple of columns that are really more like a view without having to create a full view. So you create it, it just looks like this. You know, this one here, the generated always as stored is what we had before, and you just remove the store part, and then it becomes virtual. You can also say virtual. And on this table, every time you query it, it's going to recalculate a plus b and return that as the value c. Obviously, if you just want a plus b, probably not the most important thing. But stored virtual columns really useful for things like text search, where you need to index it. But virtual columns, there are a lot of good use cases for them as well, because they're a lot cheaper since you're not having to store it. And on the topic of additions to tables, we have once again added temporal keys to Postgres. Now, if you were here and saw me do this presentation about Postgres 16, this exact slide was in there. Not entirely true, I've changed one thing in the slide, but that was more of a typo kind of thing. Because we had this in Postgres 17, and it was one of the features that got reverted because there were problems with it. Those problems have now been fixed. Hopefully nobody will find new problems, and we will have them again. So what does this really mean? Well, we've got temporal primary and foreign keys. Postgres more or less had temporal primary keys already. They just weren't called temporal primary keys, and they didn't follow the SQL standard. The idea here is we can say we have an integer, which is our traditional primary key. We have a date range that says when this integer is valid. And then we say, actually, the primary key is of the ID and the range without overlaps. Now, when you did this manually in Postgres before, you would key. The primary key would only work on equality. But we could do it, right? That worked. It's now in the standard. It's now easier to use. The foreign key thing here is you can actually have a foreign key that then includes, and then you have to use the magic word period, which is kind of interesting because Postgres doesn't have period, but it maps it to any Postgres range type. So this works for any range type. Using something like a date range or a timestamp with time zone range is going to be the most common use case, but it works with any range type. And then it says, it references this other table, which also has these two columns, and then it just has to, like it does an overlaps check on the range, and an equality check on the ID. And I think the typical use case in this is going to be you're going to have your ID, which is going to be a big int or an int, and a valid range. And then you can look at your database, historical data, it's still all there, almost like the old time travel function, except it's in user space and you can control which tables need it. But the thing that's tricky to do with that today is you can't get a foreign key that works properly, basically, today. And with this, you can. So the enhancements, it's in the foreign keys. Now, in practice, you are almost always going to want to install this b-tree-gist module, right? B-tree-gist is in Postgres contrib. It's right in there. But if you don't, then this ID would also have to be something that's gist indexable like a range. But normally, your ID is going to be an integer. And for that to work, you need b-tree-gist. So the question is this for application time only or for system time as well? So these are two concepts in the SQL standards, talk about this differently. This is fully user space, so this is application time. But it's a good foundation to build the rest. Okay, let's add one of those symbols that I thought was going to mean nothing, and I had one of my colleagues say, finally. So there's now an array reverse function. You can reverse an array. It's surprisingly how useful that is when you really need it, right? But to me, it was like, yeah, sure, now we have it, yeah. Mm-hmm. But, some people really need it, and then, it can be your big feature this time. Okay, let's move over to talk about backup and replication, which to me, I think this is the shortest section of backup and replication I've had in many, many years. But there are some interesting things going on. Partially, I'd say one of the big things that went in is this statistics transfer for update, which technically is in pgdump, so that's really backups, but it's useful for upgrades. Small thing, PG verify backup can now verify your backups if they're in tar format. Previously, you had to have plain text backups to use PG verify backup. Okay, useful. A bigger thing is you now have the ability to replicate generated columns with logical replication, right? Only stored, not virtual, that I just said were great, but stored replication. So previously, if you had a generated column, you had logical replication of the table, it would not be replicated because the assumption was you had exactly the same table on the other side, so there would already be a generated column there, and you could just regenerate the column on the other side, and that would make sense. But there are a bunch of cases where this might not be the case. You might actually be replicating into a table that does not look exactly the same. It might have a slightly other format. Like as long as it's compatible, logical replication works. You might be replicating into something that is not even Postgres. So what you can do now is when you create your publication, you can specify with publish generated columns, and it will just publish them. And also, if you don't set it on, and then it will do it for all of them, right? You can also, when you create the publication for an individual table or add an individual table, if you specify one of these columns, this is the same test table I had before, A, B, C, D, where D was a generated column. If you include a generated column explicitly in the column list, it will also get replicated.
Does it make a difference if it's virtual or stored?
Does it make a difference if virtual or stored? Yes, because it only works if it's stored. If it's virtual, you will get an error message. It is right there on the screen. Lucky me. I didn't have to say, I don't know. Because again, a lot of these are very new features. Some of them I've only tested just to make these slides. Some of them I've tested for more things as well. We have a new view called PGStats, subscription stats, that generates or collects conflict stats on the receiving side, on the subscription side. Say, how many times did you replicate an insert and we couldn't insert it because there was some other data in the way, because you did wrong. Saying update conflicts, origin conflicts. When did you replicate an update and the row that was supposed to be updated didn't exist? Like these are the classics. If you're just having a straight over logical replication, identical tables, nothing should be different, then all of these should be 0. Good to look over. But sometimes we do intentionally replicate parts of our data. We may replicate from 3 different sources into one destination. Conflicts can happen. Here's how we track them. As I said, an unusually short part on backups. Let's take a look at performance. As always, there's a lot of things. I went through, I make all my notes when I make these slides. I go through the commit logs, and I go there's a lot of stuff here about performance that I had no chance of explaining in a presentation. At least not in a presentation that's only 45 minutes, right? A lot of them are not directly exposed, as in things will just run faster, and you will just be like, oh, it's faster, thank you. Right? They're non-tunables and they're non-visible. So I'm focusing here on a bunch of the things that are visible. There have been some, and there is still a lot of interesting ongoing work to make vacuum faster. One of them is that vacuum has been redone to use the streaming I/O interfaces in a lot of places, which just means it runs faster. But what you will notice is it will more eagerly, I love this, right? This tells things for everyone. It will more eagerly vacuum all visible pages. Okay, who actually understands what that means? Couple of people, not many, right? That's really the case, right? The idea is, so aggressive vacuum is this thing we do when we're about to hit XID wraparound. You've seen it, you may have seen it. If you've seen it, it was probably painful. Auto vacuum kicks in and removes all the delays and just runs quickly to keep your system up. You're already in trouble when this happens. The idea here is you can end up in a case where every row on a disk page is visible to everybody in the system. At that point, vacuum will stop vacuuming this page and wait until it hits this threshold for the XID wraparound, and then it will do what we call a freeze vacuum to mark it as frozen, right? And your problem is, if you have your 10 billion row table, and this happens to 75% of the table at once, it becomes really, really expensive. So the idea behind this change is to actually more frequently do these vacuums, and then try to heuristically figure out if it did this and it could freeze the whole page, mark the whole page as frozen, then it's a win. And if it couldn't, then it's a loss. And it tries to dynamically figure out how far to go to sort of amortize. And the idea is to make this aggressive vacuum cheaper when it hits. It's not going to go away, but it's going to hopefully, step by step getting so much cheaper that it doesn't matter. That's the goal. What does it mean? It means you will see some more vacuums, even on tables that you didn't have anything change in. PG upgrade has a bunch of things now, more than before, that are parallelizable. So if you use PG upgrade with -J for multiple CPUs, multiple jobs, there previously would just do the PG dump and the pure copy link, but it ran a whole bunch of queries, verifications, transferring of stuff that would run single-threaded. It will now parallelize. So this, in combination with transferring the stats, can make your upgrades a lot faster. So if you didn't use parallel PG upgrade before, if you have a large database, particularly one that has many objects in them, it's mostly many objects, not size of objects, like with all things about PG upgrade, take a look at it. It's probably going to help. We have a bunch of things that you might see that you don't have to do with as just general queries. For example, Postgres will now detect group by based on unique indexes. Right? Previously, if you did a group by on a primary key and something else, Postgres knew that, well, the something else doesn't matter. The primary key is there, right? And now it also looks at unique indexes, even if they're not the primary key. So you can see basically columns disappearing out of your group by queries because they were irrelevant. Postgres now has proper row estimate for generate series for numeric and timestamp. It previously did for integer, right? If you did an explain select star from generate series from 1 to 1,000, sorry, that's a bad example, from 1 to 5,000, Postgres would get that this is going to be 5,000 rows and optimize for it. If you did it for numeric from 1 to 5,000, Postgres would assume 1,000 rows. That's why 1,000 was a bad example. Same thing, if you put in 2 timestamps, it would assume it's always 1,000 rows. Now, if you are using generate series in your production queries as well, which is not that uncommon, actually having this estimate, because we can know this, right? We don't have to guess. For most of your queries, we have to guess how many rows it's going to return. For generate series, we know, it's math. We can calculate it, it's very simple. So they will just get better query plans. Recursive CTEs have been optimized the tuple store. I've seen tests that show that recursive CTEs get up to 25% faster, which is pretty impressive because you didn't have to do anything. Right? These are recursive CTEs that do very little other than recurse. Nevertheless, 25%, it's always a good thing, right? Partition-wise join uses less memory. I still say this is one of those, it's a guy named David Rowley who wrote it, like he gets so much geek cred because he optimized JSON string escaping using hardware SIMD instructions. Because why not, right? So JSON string will be faster. Postgres can now run right-hand semi-hash joins, which might mean you will see your queries flip the order in a join from left to right if it thinks it's faster, depending on the size of the tables. Again, you don't have to do anything about it, but it might see your query plans change in a way like that. Numeric multiplication and division is faster if you're using numeric. It should really just be faster. It changed the algorithms that it uses because these are numeric, right? It's the arbitrary precision numbers, right? It changed the algorithms in a couple of different steps that it's just faster.
Because numeric is stored as strings?
Numeric is not stored as strings, but it's not like it's stored in a special magic format. It's not like you got float and you got integers, which are mapping to CPU operations, and the CPU will handle division and multiplication for us. But for numeric, they are so big we have to handle them in software, and there are different algorithms for doing this the fastest possible way. We have added, again, this has also added to Postgres 17 and removed again, the self-join elimination, which basically means if you're joining the same table into your query tree more than once, and the system can prove that this was not necessary, it will just remove it. So this, the simplest of all examples, here I'm querying from 2 tables, which both happens to be, T1 with 2 different aliases, and I'm joining it on the primary key. You don't need that join, right? So it just removes it and it scans just one of them. Now this, obviously you wouldn't write, I hope you wouldn't write a query like this. But number 1, you might have a query generator that writes a query like this for you. But also you might have views, right? And the same table is joined in 2 different views and then you're joining the 2 views, right? And there are a lot of cases where that's not necessary, but the system is now gaining the smarts to actually remove them. So we're hoping that it's better this time. Because it was in there before and it didn't hold. So again, beyond this, there are a lot of other things, performance-wise, as in almost every version, like things will just run faster. And also, commit fest 5, we just started. There are a lot more things in all of these categories that are in the pipeline to get into Postgres 18. Hopefully the things we've seen here, at least some of them are enough to make you excited about getting to upgrade to 18. Hopefully the release, as usual, is going to be out in the September to October timeframe. That's the goal. It's not a promise. Just like, again, all of these features are goals. They're not promises. Even what we have now, right, there are smaller fixes, performance improvements, yada, yada. We cannot go through all of them. The final thing that I'm going to do is I'm going to ask you all to help out, right? We don't have a beta version yet. We would expect the beta version to come out sometime in the May timeframe typically, but you can already get, at least for APT for Debian and Ubuntu, and for RPMs and YUMs for Fedora and Red Hat and on all of these forks, they are available. They build nightly snapshot RPMs. So you can just test them, right? Put them in one of your test machines. Run your application tests on them. And in particular, if we broke your application somehow, because it happens, please let us know that now rather than a month after the release, right? It's so much easier to fix it now, right? we're very happy to have that kind of information. Same if there's something in your application that we suddenly made a lot slower, because sometimes these optimizations don't do the right thing. This is how we came up, I think, with at least the reverting of the self-join elimination last time. Right? The number of people reported that like their query stopped working with weird errors because we'd removed joins that they needed. Right? But if nobody tests them, we know that your Postgres has tests, yes, but they are compared to the sum of all your applications. The Postgres tests are very limited. So throw more stuff at it. Get it rolling with those. If not, again, expect current plan is something like May-ish timeframe for a beta version, and then September, October-ish for the full release, and sometime during summer we'll be looking at release candidate versions that should be all ready to go. So that's all for me for this time. I think I'm basically right out of time, but I will be around if you have any questions. We won't really have time to do them now, I think, but just grab me in the hallway afterwards or between. I'm happy to answer anything around this or any of your other Postgres questions that you have around. Thank you very much.
So we do have a couple of minutes for questions. If anybody
perfect.
has one, I'll bring a microphone over to you. Anybody?
There's one over there.
I can just speak loud.
No, we need it for the audio, please. Is it on?
Yeah, I would say so. The talk is being recorded, so you are now being recorded.
Thank you. 3 quick questions. First of all, UUID 7, will that require installing an extension or it's built in?
UUID version 7, that's built in. There is already today, there is a third-party UUID v7 extension that you can find and install, but the big thing here is, yeah, it will be built in, so all there by default.
The temporal IDs, would that be the de facto way or the best way to build scheduling systems for booking systems and things like that? Is that what it's for?
I think it's not directly. I think today, if you're looking at scheduling system and booking system today, the time ranging is that. Now, if you need foreign keys that include the range, then yes, this is what you need. If you just need, bookings that have start and end times and not having overlaps and stuff, we already have that in general range types with exclusion constraints. But they don't support foreign keys with overlaps. If you wanted to do that prior to this, you have to write your own trigger with match and stuff, and that's all automated.
Okay, great. Last question. Does delete also have the returning clause?
Yes, delete will also have the returning clause. So you can do delete returning and get what you ended up deleting.
Yeah, excellent. That would be great for a queue system instead of, remove.
Yep, absolutely. In many cases, delete everything that happened within this time range, but let me know what I just deleted, please.
Thank you.
That's all useful. Yep. Got another one over there.
One more over here.
Yeah, it's mandatory. There has to be one over there, and then one over there, and then one over there, so that they get to exercise.
So we can play tennis, yes. My question's on the temporal foreign key thing again.
Yep.
Your examples were with overlaps. Is there any work towards strict inclusion or strict? Because perhaps on the foreign key, overlapping isn't going to be enough. I'm going to want to know that it's strictly contained or that the parent is strictly.
So I don't think there is any work on that right now. I don't think that's, because the work right now is based on what's in the SQL standard, and I don't believe that is in the SQL standard. Maybe someone can correct me if I'm wrong, but I don't believe it is. You can still accomplish the strict containment things today, but again, you have to do it sort of in user space with a trigger, because Postgres range types will have the ability to do strict containment, but the SQL standard mapping functionality, I believe, does not, and I haven't heard of anyone working on it right now.
Okay. Everybody good? Perfect. Well, once again, thank you, Magnus, for coming out. Certainly